When is the stupid bus gonna come? I'm hungry.
I don't know.
Hey little boys, want some candy?
Konnichiwa, old man. Is it tasty?
Yeah, what flavor is it?
You're just gonna have to find out.
Well, I'm an aspiring pastry chef, so can you tell me how it was made?
That's a really convenient question that will lead to a scientific portion.
Man, I can't wait for tons of little children to flock to these candies.
Don't be silly. We'll get at most too.
Yeah, you're right. Anyways, how are the lollipops going?
Well, the molecules in the pot have started bouncing around at very rapid rates, making what we perceive as heat.
Well, I get that, but how exactly do these ricocheting molecules make the sugar melt if it's just something that we perceive as heat?
Well, you imbecile, you aren't looking at this the right way.
What do you mean?
Well, since it is something that our bodies have to translate into a sensation, we view it differently as how it is. The movement of molecules and atoms hit each other, transferring energy, rather than something like energy coming off on waves of heat off of each atom, and that energy provides the power to break and make bonds, like the melting of sugar.
Okay, but
Anyways, when the fast-moving molecules in the pan hit the slow-moving ones in the mixture of sugar, water, and corn syrup, the energy in moving molecules hit the stagnant ones and give them energy for hitting the molecules near them to create chemical reactions. This entire concept is known as kinetic molecular theory, which can also be stated as heat directly correlates to speed.
this is a lot.
It's important to remember that we're talking about speed here, not velocity, because the molecules in solids don't have much room to move, so they're constantly hitting each other and changing direction.
Then that leads to IMF, right? The sugar starts melting, which is the intermolecular force that holds it together to keep it from breaking apart, right?
Well, actually no, but good try. Sugar melting is a chemical reaction, but water evaporating changes in IMF as the hydrogen and dipole-dipole bonds holding the many water molecules together break, allowing the water molecules to spread out and take the form of water vapor.
Well, you got your monologue, so I think I should get mine. So get ready to get schooled in IMF. When water melts, the intermolecular forces between the water molecules are decreasing, but when water evaporates, stronger intermolecular forces increase the energy difference between the liquid and gas phases of any substance. This is because water is composed of hydrogen bonds. Just for the reference, the 5 kinds of bonds are hydrogen bonds, ion-dipole bonds, dipole-dipole bonds, and London dispersion forces. The strengths of these bonds are descending in order, with hydrogen bonds being the strongest and LDF being the weakest. And keep in mind that this only applies to the things within a similar size and amount of bonds. This means that if you take something like plastic with multiple LDF bonds, the overall bonding strength will hold itself together better than a single hydrogen bond holding 2 water molecules together. London dispersion forces are a unique kind of bond, as they are in every other kind of IMF bond. This is because they are based on the fact that different charges in different particles of electrons clouds will attract, creating weak bonds anywhere.
Wow, great. I totally cared about that and paid full attention to everything you just said.
Well, I'm glad, because knowing about these bonds will be super useful, even if you don't get a chemistry-related job.
Yeah, right.
I hope you got the gist.
Yup, that'll really help with making spaghetti for my Oni-sama.
Where are we going? I left my scooter at school.
Use your inside voice.
Fine. Oh, you wanna know something? I know how this van runs. So, it actually runs on a combustion engine, which means that the gas that you put in the tank combines with the oxygen that's already in there, and it makes the wheels turn. The chemical reaction is occurring between the fuel and the oxygen that is in the gas tank. This is called a combustion reaction, and the equation for that is fuel plus O2 equals CO2 and H2O. Yeah, it's pretty cool. This is only one of the many chemical reactions that happens to make this van move. Also, I farted. Also, did you know that the gasoline that you put in the tank is actually over thousands of different chemicals that people just put in the pot to make it, they hope it just works. It's like another kind of pot. Also, I learned that there are many types of chemical reactions in school today. There's synthesis is the reaction that makes the simpler materials. The 2 compounds are bonded together. And then a decomposition is the opposite of that, where they're taken apart. Yeah, it's pretty cool.
How do I get him to shut up?
compounds are broken down into the elements that make it up. The combustion reaction is when a compound containing carbon and hydrogen, and sometimes oxygen, combines with oxygen gas to produce carbon dioxide and water. Single replacement is when one element that starts out by itself replaces another element, kicking it out. In the words of a certain chemistry teacher, it's like when person A and person B are dancing, but then person C takes person A and person B from person B, and then person B just has to sit on the side and drink Kool-Aid. And then there's a double replacement reaction where the positive and negative ions both switch.
Okay, you just got to my place, so you need to shut up. You know what? You blindfold the other one and park the car. Come on, you're coming with me. You too, go!
Shota Mate! Don't take us to a secondary location! When kidnappers take you to a secondary location, you'll usually be dead within the first 24 hours.
Good job.
I'm hungry! Mommy! I'm hungry too!
Why are you hungry? We just fed you lollipop.
FBI, open up.
Well, shit talking mushrooms.
You stay here. I'm gonna go see if the dungeon is still in business.
Yeah, you take every schoolboy to the dungeon. I think it's valuable.
Let's go.
Wait. FBI, open up! Looks like the directors ain't cooperating. It's time to fire in the hole.
Yes, sir.
Fire in the hole!
You know, in the last moments of my freedom, the first thing that runs through my mind is, why does the gas from a smoke bomb move towards you? And why is it warm?
Wow, today is just full of convenient questions, huh? Well, it's all due to the gas laws, starting with Charles' law, which states that the heat and volume are directly proportional. There's also Boyle's law, which states that volume and pressure are inversely proportional. Finally, but not really, there's Gay-Lussac's law, which states that temperature and pressure are directly proportional. Something that isn't a gas law but still applies to gases is that gases that are more pressurized than the gases around them will diffuse across said gases, or even out. In the situation of a smoke bomb, the smoke spreads because the smoke is heated in the gas well from a chemical reaction. This heat causes an increase in both volume and pressure. Since the pressure outside of the bomb is lower than the pressure inside, and the bomb is open, the highly pressurized gas will diffuse across the room. You might think the gas would run out before it can create an actual smoke screen, but the increase of heat also increases volume due to Gay-Lussac's law, so there is enough gas to spread. Because of the increase in volume, you might think that the gas would thin out and wouldn't act as a proper smoke screen, but the pressure compresses the gas due to Boyle's law, so the smoke screen stays a smoke screen. These three laws are all applicable in real life. However, there is a fourth law that really only applies in chemistry called Avogadro's law, which states that volume is directly proportional to the number of molecules in a gas.